Hi, this is Kenneth Wong, Senior Editor for DE. Dr. Guha leads a class called Master of Engineering in Additive Manufacturing and Design at Penn State University. Like many other university classes, his class too has now gone online due to the coronavirus outbreak. As I speak to him, I am myself under lockdown in San Francisco by a statewide shelter-in-place order. Dr. Guha, welcome. Would you mind introducing yourself and tell us who you are?
Sure. Thanks, Kenneth, for having me. My name is Guha Manogharan. I'm a faculty in the Department of Mechanical Engineering at Penn State University, and I'm also a key faculty for our Masters in Additive Manufacturing and Design program. And this semester, I'm teaching Metal AM graduate lab course, which is one of the required hands-on lab course for our program.
Okay, so Dr. Guha, what was your class routine like before the virus outbreak and what's it like now?
So before the virus outbreak, our class routine was the class was broken into smaller groups, and we had a round robin schedule where one group was working on reverse engineering, one group was working on manipulation of the point cloud data, one group was working on learning how to set up a build plate, selecting support structures, and one group was working on process simulation, while other group was working on characterization and so forth. So this was the routine before this virus outbreak.
All right, and now it seems like many other professors and university lecturers, you have had to gone online, probably on Zoom. So how does it change the way you teach?
Sure, it is definitely a different environment. But one thing I do emphasize to the students, and the students also understand that given the environment that they would be working after their graduation, where their company might have sites at different locations, we look at this as an opportunity to get even better at teleconferencing and working as a team from remote locations. So that is a big shift in our philosophy. Now we teach this course, and now I have to give a lot of credits to the students, and how they have also adapted to this unusual situation. And regarding this course, fortunately, we were able to collect a lot of data from some of the groups during the round robin situation, where some groups were doing characterization, some group was doing reverse engineering. So we had those data that are now shared through our online data repository. So that has helped the other teams to continue to work on their course as originally planned. And also another opportunity that has arisen from this situation is we are now using 3D systems, 3D Expert, through a virtual desktop, where now the students are able to access the software as if they are in the lab themselves, in addition to having 3D system support, where now they have access to the tutorials as well, where the students are continuing to work on their final project, which was originally scheduled to be printed towards the middle of April. But depending on the situation, we will probably print it later in the semester. But other than that, this has been a really good opportunity. And now the students among themselves, they have set up their own individual Zoom meetings, where in order to motivate themselves and to work as a team, there are smaller groups of all of them working on completing the tutorials for 3D Expert and applying it to their final projects during this situation.
So one of the things that is particularly difficult to master with designing for additive manufacturing is the distortion compensation, I believe. Engineers talked about that a lot. Under normal circumstances, you can print out a part and you can measure it against your CAD model and see how much deviation happened during the printing process. And then you go back to the CAD model and redesign it in such a way so that you can fix the anticipated distortion. How is that part handled now that you have to do everything remotely without access to the hardware?
That is a really good question, Kenneth. A couple of things. One, we have been fortunate to have had this course in the past semesters and in the past couple of years. So I was able to dig back those data and provide those data for the students as case studies, where they are understanding the impact of build orientation and laser processing conditions and so forth. But the second thing that we are able to do now is actually dig a little deeper And instead of looking at distortion compensation as a plug and play as another feature where you kind of check the box before you go on print, this situation has provided a really good opportunity for the students to understand the impact of selection of laser strategies. Even though it is virtual, they're still able to understand the impact of different support structures and its impact on distortion, understanding the efforts of the different post processing that we would be doing, such as machining or abrasive flow finishing, and then planning for those. So, in the first portion of the lab that we were doing before the shelter in place, we did some on simple coupons, not necessarily on final parts, but on simple coupons. Now the students are able to leverage that experience and that data along with the past information on reverse engineering and distortion models that we have had and apply it towards their final project. To give one specific example among few, one group is working on 3D printing helical gear box. So now they were able to predict the distortion and then understand its effect on subsequent post processing in terms of machining elements. And now they are almost ready to get their final part ready for printing after several runs of distortion compensation.
Let's talk about the technology involved in this kind of remote teaching then. So you're using, among other things, 3D experts from 3D systems. Is that the sort of software where you can actually share a session, or do you share what you are doing on your screen through some kind of screen sharing function? How would that work in collaborative processes?
Sure. So far we have because again the software I have to give kudos to the IT team in the Department of Mechanical Engineering. They very rapidly set up the virtual desktop for multiple students to be able to access the software suite that is required for additive manufacturing. So as I previously mentioned, the students now use Zoom Share, and I also do Zoom Share with the students where we go through the different tutorials with the students.
Very good. Now, lately, 3D printing or AM has seems to emerge as the technology to address the shortage in face shield, the address shortage in ventilator parts because people are able to just crank them out from their own 3D printers at home without setting up any kind of complicated machine shops and things like that. Does it change the way you teach this class, or does it change your curriculum a little bit?
That is a really good question as well. So one of the things that I have done in this course, and I know several of my colleagues have done in the other 3D printing courses that they teach, for example, an undergraduate 3D printing course, where this is Dr. Tim Simpson, where they actually use this as an opportunity to make it a design challenge for the students to develop a design for additive manufacturing for face shield or for ventilator components that would be rapidly produced. So that is at the undergraduate level. At the graduate level, in the course that I am teaching, I'm involving the students in understanding the effects of design for AM on post processing from the metal side of things.
Dr. Guha, as a response to the spreading COVID-19 crisis, are there opportunities for your department to collaborate with other departments at your school?
Sure. So it has actually it is an effort beyond just the department. I have to give credits to Dr. Tim Simpson, who led the effort and who did a fantastic job in establishing Penn State's manufacturing and sterilization for COVID-19 MASC initiative, which aims to leverage Penn State's research enterprise to innovate potential solutions to address healthcare needs required. And this includes College of Engineering, College of Medicine, College of Architecture, College of Material Science and Engineering, and everybody within the entire Penn State ecosystem, including Material Research Institute. And Penn State is also a member of the COVID-19 Healthcare Coalition. So we have a very robust and very active team on campus who are actively working with our medical school in leveraging our expertise in design and advanced manufacturing on how to help our community.
As a response to the spreading COVID-19 crisis, Are there opportunities for your department to collaborate with other departments at your school?
It is an effort beyond just the department. I have to give credits to Dr. Tim Simpson, who led the effort and who did a fantastic job in establishing Penn State's manufacturing and sterilization for COVID-19 MASC initiative, which aims to leverage Penn State's research enterprise to innovate potential solutions to address healthcare needs required. And this includes College of Engineering, College of Medicine, College of Architecture, College of Material Science and Engineering, and everybody within the entire Penn State ecosystem, including Material Research Institute. And Penn State is also a member of the COVID-19 Healthcare Coalition. So we have a very robust and very active team on campus who are actively working with our medical school in leveraging our expertise in design and advanced manufacturing on how to help our community.
Very good. Dr. Guha, thank you very much. I wish you and your student safety and good health.
Thank you so much, Kenneth, and thanks for having me.
Well, this is all for this episode. I'm Kenneth Wong for DE. Thank you very much for tuning in. Bye bye.